Hello, this is Team PokerRL, and we're going to share our progress report.
So our problem description is we initially started with blackjack and then we switched to poker because it was more flexible. Our TA suggested that we use the OpenStreet library, which contains a universal poker environment. And our current goal is to experiment with basic agents and algorithms in the environment and then scale them. So these are the five different algorithms we have. And then the environment is that it's a simple environment in OpenStreet where players can see their own stake, current round, amount spent, like the rewards and losses they have, and which player's turn it is.
So for our CFR algorithm, we saw that CFR-BR had the highest exploitability, ending at 0.05, and CFR Plus had the lowest exploitability, ending at 0.02002. With regular CFR, we saw that it converges to 0.01 because it iteratively computes the counterfactual regrets and updates strategies via regret matching. And for CFR Plus, which was our best one, we saw that it applies a positive part operation to regrets, where basically negative regrets are reset to zero, and also uses linear averaging, which is why we get such a low exploitability. And finally, we got CFR-BR, which reduced to 0.05, and we didn't see significant changes in exploitability here.
For a PPL algorithm, you see in the beginning, the episodic return was practically negative, and then towards the end, it was ranging around 250 to almost 300. And so, as you can see in the graph, the episodic return increased over time. It eventually found better strategies, so it improved. And then the average actor loss was stabilizing, indicating convergence and incremental policy improvements.
And our last algorithm is NFSP. Here we're training two agents that are playing against each other, and so as they're learning in the early stages, their win rates are very far apart. But as uh, the iterations continue, it starts to converge to zero, showing that um, the average return is going to zero, meaning like they're more even, least skilled bots. And so the results show that the win rate of the agents against random agents seem to converge to around the 45% win rate mark. And the average return is also converging to less than 1.0 for when the agents play against each other, showing that it is approaching an approximate Nash equilibrium. For the next steps of our project, we are going to be comparing these different algorithms more and see their performance using changing parameters, uh, and we will uh, train against each other. So CFR agents against NFSP, NPPO, et cetera, et cetera. And we will see what is the most optimal algorithm for poker in these situations.